Okay, this doesn't look like an integration question at all at first glance, but it is really because we've got this curve y equals f of x, but they're not telling me f of x, they're telling me f dashed of x instead. The other thing they have to tell me is a point on the curve for reasons we'll see. So our starting point is f dashed of x, and I want f of x, so I could use that notation, or I could say dy by dx. That means the same thing as f dashed of x, and that is this expression 2x cubed minus x minus 8. Okay, I want to know, if you like, effectively what f of x is or what y is. So f of x or y, how do I undo the differentiation? Well, we've got a new shiny way of doing that. We integrate. So we've got to do the integral of 2x cubed minus x minus 8 dx. Don't forget the dx. And then these are just powers of x. So for the x cubed, new power. When we integrate, we increase the power. So the new power of x is x to the power 4. And we divide by the new power. 2 divided by 4 is a half, or 2 over 4 is fine, but cancel if you can. Next one is x, which is x to the power of 1. So the new power of x is going to be x to the power of 2, because we increase the power when we integrate. And we've got a minus 1 in front of it. We divide by the new power, so that's minus a half. Okay, and we've got a minus 8. Constants don't disappear when we integrate. The thing that differentiates the minus 8 is minus 8x, and we must never forget the plus c. In fact, this question is a really good illustration of that, because we've got to now use some more information. This point here, that's coming into play now, because we've got to use it to find plus c. So we've got this point minus 1, 4. Okay, that implies that we've got an x and a y, lob them in. We substitute in our 4 and our minus 1 to get this equation, and then we simplify everything so that these two cancel out. Okay, and c is minus 4. But of course I haven't finished until I've actually stated my f of x. Here it was, but I need to state it with that c included. So this is our answer to part A, and we double underline it. And here's that answer, because we're going to need it in B, but I want to be able to see the question as well. So in B, we've got to find an equation of a tangent. And an equation of a tangent requires me to have a point, and it requires me to have a gradient. Okay? So, well, it talks about a point. It says the point has got x coordinate 2. So I know the x coordinate is 2. I need to find the y coordinate. Well, I've got the equation of the graph. Y is f of x, here's f of x. So I'm just going to have to substitute my x equals 2 into that. So it's a half x to the power 4 minus a half x squared minus 8x minus 4 with a substitution of 2. Put all of these in. Half of 16 is 8, minus a half of 4 is 2, minus 16 minus 4 equals 8 minus 22 is minus 14. Yep, I think it is. So our point is x was 2 and y is minus 14 is our point. Gradient, I'm going to have to do down here. So gradient. Now, what we'd normally do is find the gradient by differentiating our f of x. But there's no need, because they've told us f dash of x earlier, and I integrated it. So my gradient, okay, well, I don't want to do f dash at any old point x. I'm interested in the specific gradient at this point, where x is 2. So I'm going to substitute my 2 into that. So f dash of x, I'm going to be doing f dash of x equals 2x cubed minus x minus 8. And I'm taking x to be 2. So we can go the 2's, and that's 2 times that's 16, and minus 10 is a gradient of 6. So putting everything together, we've got a point and a gradient, so I need to do y minus y naught equals m brackets x minus x naught. Okay, and I can't leave a double negative in it. I might as well multiply out. So that means y plus 14 equals 6x minus 12. And I can even get to y equals mx plus c painlessly. So y equals 6x, subtract 14, minus 26. Double underline it, because that's my final answer. and I'm laughing all the way.